Hey guys, Cryptic here, and in this tutorial course we will learn about everything we need to know about C#. In the first episode we will talk about the basics of programming. In the second part we will talk about the Unity specifics of C# and using events and all the kinds of stuff like that. In the third part I will talk about, this is a bonus chapter and bonus part for you, is how to think like a programmer. So if you guys are interested, watch the video till the end and I will show you how to go from a beginner to an intermediate or kind of semi-expert in game programming. So if you guys are new, make sure you subscribe and hit the bell if you don't want to miss anything, and I will see you in the course. Welcome back everybody. So in this video we'll be talking about variables. If you are new to programming, do not skip this part, but if you are not, go ahead and skip to this part, to Unity specifics programming, where we'll talk about how you guys can use the knowledge that you have to create the game. But if you are new to C#, don't even think to skip this video because you will miss out a lot of things. Okay, so let's get started. Do not worry about any of these, but worry about these two things. You need to understand them. What are start? Start is basically a function that calls when the game starts. Simple, right? So I have rewritten the comment. Start is called when the game runs. Okay, game starts. That's much more easier. Update is called every single time when you are playing. Now I have a simple quiz for you guys. You don't have to write it down or do whatever you want, but you have to give me the answer right now. Is if I say score equals to 0, where I will put it? Into the start function or the update function. You have 5 seconds. 1, 2, 3, 4, 5. If you said start function, you are right. So score, when you set the score to 0 when the game starts, then something happens, like something collides or the player gathers some things, then score gets increased, right? So that's why we're going to be using some variables to hold that data, how many scores are there, so you can use that data as much times as you want. So okay, so let's get started. First let's look at the type of variables. Are many types, but there's one type which is number. So if you want to hold a number, you will write int, then you will name the variable. Let's say score. Then when the game starts, I will say score equals to 0. Now let's put and print that score. So let's write print score, and when I hit save, the compiler will run and our console is happy, no errors. Let's run, and in the console, come on, oh okay, I forgot. First you need to put the test or the script somewhere. So let's create a new empty game object. Let's write test and put that thing down in there. So just if you haven't watched the Unity video, go ahead and watch it, because this is not a Unity course, this is a C# course. Okay, save this and then run, and we will see that it is indeed 0. Now let's go ahead and change that value. Let's say when the game starts, I want the score to be, let's say, 100, and hit save. Go back and it will compile. The compiling takes years, and then when I run, and this is going amazing. Now when the game starts, score equals to 0, and then we print the score. Then when the game is running, if I hit the space key, I will increment the score. That's what I'm going to code, but later. But for now, understand this is start runs when the game starts and update runs while playing the game, while everything is happening. So there are multiple types of variables to work on. So first we have int, then we have float, which holds decimal values. So let's say speed can be a decimal value. Then we have a string which holds a word or a sentence. So I can say name, and we can say name equals to cryptic. I will do that, but for now we'll have another type which is called boolean. Bool means true or false, so we can say is alive to true, right? This is called camel casing, by the way, for those of you who don't know. And let me talk about the structure of variables are and how they're used. The structure of variables are the float, the name type, the type of the variable, then the name of the variable, then we have the semicolon to stop it. Now in many different languages you can actually provide a data, let's say an equal sign, and then say true, but it is not, it will not do that. It will not give you the permission to do that. It will scream at you. Okay, so if you don't want to get screamed at, what we'll do is when the game starts, I will say is alive to true. Now it will know that is alive to true. We are now alive. Okay, so this is basically how variables work. There are a lot of stuff going on here. So now I want to change that value here, because most of the time when if you downloaded any templates and stuff, you will see that there are values here. You will just, like, for example, this is the player, and the values of speed, stuff, and gravity is already over here. How do they do that? They will do this by using the public attribute. When you are not doing anything, when there is no declaration on whether it would be a private or would be a public, then it will be private in default settings. So if I say public here, so the main syntax is it public or private? This is called accessor. If I'm not wrong, it's accessing modifier, the type, and the name. For those of you who know what are these things called, do let me know. I actually forgot. So public and the type and the name. Then if I hit save and go back, as you can see, we have, wait a sec, we have a score property. I can now change to, like, say 100 or 1000, right? Then what I'm going to do is I'm going to close everything up, and let's just print up score and just see what happens. So we look at here, the score is actually 1000, and if I run, score is 1000. You can see here. So this is how it works, but in programming practice it is not a really good practice. What you will do is say private, because it is bad design practice or object-oriented design practice, because we will follow those terms, to make your variables public. That's just not a good idea. So what we'll do, what you will do here is use the serialized model field. It's a little advanced, I know. Serialized field, please. Does that work? Please work, and hit save, and now Unity will scream at me in 3, 2, 1. No. Okay, whatever. So let's just run, and let's see 1000. Okay, so let's just recap here. Now if I just remove the serialized field and I'm going to save, see, this is a private field, right? I hit save, and the score, the property, removes from itself. What is wrong with this? I don't know. So the property removes. This is now how it will work, right? You need to create a serialized field to know that this is a serialized field, and we will use this field and show this field into the inspector view. Now I'm lagging, I know, but still I'm trying my best here. So save, and we will use this term a lot, so get familiar with it. Space, and space. and I will hit private, and I will hit private, and I will write private and hit I. All of these are saved, and I'm gonna just open up. This is Windows 11, by the way, and we have ourselves speed, we have name, I can say cryptic, and I am alive. Obviously I'm alive, right? Okay, and what I'm gonna do is, this is how it works. This is the basic fundamentals of how variables work. If you have any questions, go ahead and ask me, but if you don't have any questions, that's amazing. So thank you for watching. It's about how many minutes left? Doesn't show. Oh, it's 10 minutes of content, and in the next video we'll talk about the complexity of variables. Thank you for watching. I will see you in the next video. Hello guys, welcome to another video. In this part we'll talk about the advanced variables and how you guys can use them. So what I'm going to do is, when the game starts, I'm going to change the cube's material to something else. That's what I'm going to do. Okay, how am I going to do that? First, we need to think carefully. First, think about that what I need to change exactly. Okay, so we have ourselves a cube. So the cube has a material mesh renderer in the material function, and as you can see, we have a default material. Now I'm gonna create a new folder first, materials. Then go inside the folder, right click, create, and a material. Where is the material? There you go. So I'm gonna say cube mat for material. Then I'm gonna change its color, and I'm gonna drag and drop this guy to here. As you can see, it's changed. Then we know that to change a cube's material, you need to get the mesh renderer. We need to change the material option to a certain material. So there's two variables that needs to be done. First, the material. Next, the cube's mesh renderer. Hopefully you understood. Let's go coding. So let's go ahead and remove everything. Wow, my mouse is not working today, so I need to make a goddamn video. I'm just gonna remove all that. Let's go ahead and say serialized field. Serialize field for some reason doesn't work. So private, I'm gonna say mesh renderer renderer. Yeah, a renderer. Then let's go ahead and save, and let's see if it works or not. So we would have the score does not exist in the current context. Sorry about that. Save, and let's see what happens. So in the cube, come on, please, quick. In the test, we have ourselves a mesh renderer, right? But it depends. Remember that a code can be executed from anywhere. That depends on a game object with a script. You can put this code, the same code here, and you can also put this code anywhere else, and then put the material and the mesh renderer. But what I really want is to show you how you guys can do it from anywhere. So we're gonna put the mesh renderer over the test. Okay, so let's go ahead and see. As you can see, we have a what is it called, an option to put this thing, and if I click on that, I can say cube, and the cube's mesh renderer has been set. Then I'm gonna copy, because I don't want to write, so copy, and I'm gonna say private. Let's see, what is it? It's called material, mat and material. So when the game starts, you know what to write, right? So renderer dot material equals to material, and material equals to material. And let's see what happens when I do that. First, let's save. We have reset this. Let's clear this thing out. Okay, we have reset this. Now I'm gonna go to the test. I'm gonna put this guy over here, put the material over here, and if I run, And as you can see, it still got changed. Now, now if I want to create that, when I click on a particular button, it will change, but we will do this later when we will learn about if statements. For now, you understand that how to do some things. We can set up multiple materials here. Right click, create a material and another cube mat. Then I'm gonna write this guy, save this guy, go to the rest and put this guy here and then run again. That's the power of variables. So you can put in a lot of stuff. So I can just put this guy here, put this guy here, and run this again. It will work. This is the power of how variables are super powerful. Hopefully you understood how you can use this knowledge for your advantage and how you guys can use them. So thank you for watching. I will see you in the next part. Welcome back. In this part, we'll talk about the if statements that you guys were waiting for, because this is one of the most important stuff. If statement is basically checking different things, and depending on if something is true or if something is false, do some things. That's about it. Basically, the way if statement works, you write if, and here you see this, you hit tab, and as you can see, this thing popped. First you need to do is just say, is a condition, and if it's true, then the command execution. Basically what happens is, if this is true, there will be a variable or a condition, and depending on that condition, whether it will be true or whether it will be false, depending on this, if it's true, then run this, except there is another one called else. If condition runs, then do this. If it fails, then do this. That's about how everything works. So let's go ahead and see. Now, if you want to take input, now we will say, I actually forgot how the heck I'm going to do that. If input dot get mouse button down 0. First, let's go ahead and see, get mouse button down. No, get mouse button down 0. Basically, first I'm gonna have to check something. Wait a sec. Done. And I hit done. Please work. Please don't scream at me. It should work now. And if I hit hello. Okay, I'm an idiot. I put this thing in the start function. I have to put this thing in update. Yay. So what I have done is, let's understand this code here first. Input is the class that controls the input of from the hardware to what will show into the screen. So basically, input is done in different formation. You can use the controller that has a different input. You can use the mouse that has a different input. You can use the keyboard that has a different input. What this will return is, if I click on them, if I click on somewhere here in the game, this condition will run. So let's see if it runs or what. And I'm gonna do is save, and it will hit here, and as you can see, done is getting printed, and 1 2 3 4 5. That's how it works. Now what we'll do is, instead of saying that render.material is here, what I'm going to do is just cut this thing off and then paste this thing here. And I'm going to remove the start function, but let's just stay here because we will need them someday or later. So let's go ahead and let's see what happens. As you can see, it is white, and if I click, this thing is blue. That's how conditions work, and with these two things you can basically create a lot of. Alright, you understood the basics of if statements and how they are used in different conditions. There are multiple different if statement types, and we will look at them step by step of how they work. And there are multiple types of programming as well, and there are multiple rules. There are a lot of stuff. So yeah, in the next section, we will look at each of these, and we will go depth of how they can be used in movement of our character. So welcome everybody. In this video, we'll be talking about functions and how they're used. First, let's look at some of the functions. First, let's look at the start function. We all know what is the start function. Start function is the function that runs when the game starts. Update function runs when the game is running. Fixed update functions every single frame, but it is used in calculations of the vectors and all the mathematical elements that comes with. There's another one called the late update. This is used for camera movement, and this is used for character movement. So character and any type of physics related stuff. Physics. I don't know how do you pronounce physics. How the heck? I don't know. I don't know. Yes, I'm dumb. And there is also user-defined functions. Okay. User-defined functions are we write by name private, then and a void. Now the void meaning I will explain. Then we give it a name. So for example, move. Okay. So why are functions used to actually block the code, and then this will make your code more readable, because if your code is not readable, then after you have come after like 5-10 days, if you're working on the game, you come back and you're like, what the heck I coded, what the heck is this, and why the heck it doesn't work. So you need to make sure make it as readable as possible. That's why function is one of the important things. Function is another really, really important thing. There's a principle called dry, which means don't repeat yourself. If you understand the solid principles, the D of solid is dry. Don't repeat yourself. The main factor is a function. So let's look at the practical examples and I will show you. First, let's go ahead and let me just say in the start function, this is really important. We would go ahead and write int x, and I would in the move, or let's just write set for now, and set in the set function, I'm gonna go ahead and put x equals to 10. And remember that we need to call the function, because you think about it, it's a block of code. It's a block of code, and this is like a gun. The bullet is the function. If you don't trigger the bullet, no need for the gun. The gun is useless, right? If you don't trigger the bullet. That's the thing, how functions work. They're like the bullets. So you fire them. You have to fire them to activate them. That's how it works. So if I say set and put it down, and if I hit this, and I'm gonna I'm gonna say print. Okay, so let's go ahead and save for them before this one. So this one work like that, and don't look at here. Look at over here. The console tab is the right. Alrighty. So the int x and the private set void the start, and we have the setting x value. Next, you can do a lot of stuff. Think about the naming of a function. The name should represent what the function is doing. For example, if the function is doing moving the player, you should write movement. If the function is doing movement to the right, you should use this is called camel casing, and the movement to the right. Then what we have is the getting of the functions, meaning getting the value. I will explain. Don't worry. So first for private, then what type of value are you trying to return from it? So let's think about it. Let's go ahead and just say x int get x, because what I'm gonna do, return. Now, what's the difference between returning and what's the difference between the printing? Both will do the same thing. Okay, so in here, instead of printing there, here x equals 10 set and x equals 10, and then I just set. Okay, so let's run the set does not exist in the current context. Oh, sorry. Let's change. So save, go back, and if I hit plus icon, sorry, the play icon, it returns 10. Now, what's the difference between this and get? So get, you can use this value as the return statement. So how can I use them? So if I use get x, okay, and I hit this, let's name it print x. Okay, okay, save and get it. Now you would see this thing returns 10. But I also write get x. It should have returned x, right? What returning does, please be as mindful as possible and focus. The function, what it does, what the return does, it deletes and then it writes 10 because the x value is 10. So now, is it possible for the compiler to know that it is 10, right? Then what the heck I'm gonna do with this 10? So that's why what you need to do is just print. Goodness, print. Then you have to write get x. Now what it will do, the compiler will come and say, okay, get x. So I'm gonna remove everything and then write 10. Now, is it possible for the compiler to run 10 and then print it? Obviously it is, right? That's why you need to use print, and you can actually store the value, but you cannot store the value when you are printing. You can store the value. So let's say int y equals to get x, and y equals to y plus 10, and I print the y. I print y. Okay. That's how it works. And if I now go run value y and value, and as you can see, the value of x is, if you can see, the value of x is 10, the value of y is 20. So why? Because what the return does is just this. And it can use literal, the int. You can use string, you can use literal anything, no worries. So that's how the concept of works, the concept of function. Welcome back everybody, Cryptic here. In this video we were talking about function parameters. So let's get started. First, what is a function parameter? A function parameter is the input to the function. For example, you have yourself a function called private void calculate area. Now, is this possible for that calculate area to work without the width and the height? No, right? So that's why you need to give it some values. So int width and int height. Now why int? Int meaning the what type of data this one will accept, and the what type of data height will accept. So width will accept a int and the height will accept is always a int. So if it means that the width cannot be, let's say 13.3. It cannot be like that. So the area must be a whole number. That's what int means. So the reason we are doing this here is now we have access to width and height. So let's say I can say area int area equals to width times height. Then let's return the area. Hopefully now guys understood what a area is, so we don't need that. We can just say integer. And then in the start function, what I'm going to do, in the start function I'm going to say integer area var equals to calculate area. Then we need to give the value. So let's say 20. Now what I'm going to do is just say print area var. Then we need to save this guy right here. So let's save this guy and go back to Unity, and I'm going to show you how to do this. So let's go ahead and make it work, and let me just close this thing out please. And it's working, and we're going to go to the console, we'll release them and we'll start. So we have ourselves, we're going to just clear this thing out, and I'm going to start play. Now don't look at the eagle name and all the kind of stuff. Look at here. We have ourselves the 400. 200 times 200 is 400. So this is what I'm going to show you. These things are, this is later recorded, so we will come back to this later on. But for now, just go ahead and let's see. Come on, 400. That's what I'm going to show you. So how it works? Basically, it takes some variables, and depending on that, takes some things that it requires to work. Then it takes them and may make something out of it. So this is basically how most of the functions work. Like say, let's say print, right? This function, if I go inside of it, which I cannot go right now, but if we go inside of it, you will see that this thing is also a function that is triggering some hardware stuff, and that's why you are able to print. This is nothing more than a print. This guy is nothing more than a print function. See, the lettering is also the same. So that's how you use parameters in your function. Now, why parameters are useful? Let's take an example. Let's say you need to make sure that your code runs from anywhere. What you will do is say private. Let's add a code that says what it would do. It would follow the player. So follow player. So then I can say rigid body. It takes a rigid body player, or let's say a transform of player. Transform of player. Okay, so now when you need to run the follow player function, you need to give this transform to player. Now we have ourselves a player, and then what I'm going to do is just say player dot position. I can say that, let's say transform dot position equals to player dot position. Okay, so transform, make sure I'm gonna show you the test is the enemy. Then the test is the enemy. When it follows, it takes the player. When it follows, it takes the player, and then when the player, and we just setting up the position to the player's position. When we write them, we need to give it a player. So say follow player, and as you can see, it takes if you hover over it, says for test.follow player transform play. It requires a transform. So now we need to give it a. So say private transform player, and then we need to just pass in the player over here. So I'm gonna just pause for a minute, and hopefully you guys understood how the follow things and any type of artificial intelligence can be coded using parameters. It really requires a little bit of thinking that what it needs, right? What it needs. Depending on the need of our function, we need to give it those things. So an area requires a width and a height. A follow player requires a player object to follow, because it doesn't know what is a player. So that's why you need to think carefully about what it requires when you are coding your own functions. Hopefully you guys understood. I will see you in the next video. In this video, we'll learn about lists. So let's get started. First, what are lists? Lists are a variable that holds multiple type of its content. And simply, a list of int may hold 90, 100, 2000, 5000, etc. It can hold in a single variable. Then it can hold in a single variable. All right, so first let's go ahead and learn about lists. What are lists? We talked about those. Now let's go ahead and write the list. So I'll write list, and the type of the list will go over here. Into the third, they're like brackets type things. Yep, so I'm gonna say int, and I'm gonna write scores. And in the start function, I will write start, and there you go. And the start function, I'll say scores equals to, let's look at the documentation to get more understanding on how scores work, because I don't want to just teach you, I want to teach you how to even think. So go ahead and go to your documentation, and this guy says that importing this line of code is required, so we did that. And we will go over here, and as you can see, we have a new list. We need to initialize. This is called initialization. Basically, new mean it's the value of this value will be 0, or there will be nothing. And we can add them like this. And let's go ahead and let's see. Okay, let's go ahead and let's see how it works. So in the start function, we have to say new list of int. And look at the syntax here. The scores is the scores variable, equals to means equals to, new means new, list mean list, and there's a type is int. So we give a new of the type. Now we need to add. You cannot just say scores. Like if you programmed before, you would think like that, like 100, 200. It doesn't work like that. You need to do it step by step. So what I'm going to do here is say, let's say scores.add 100. Int will only store int. Int will not store string or bool or any other type. Then what I'm going to do is just return print scores. And let's go ahead and save, and let's see how it works. What I'm going to do is open up our Unity editor, and I'm going to run. And we would instantly see that the scores is a type of int32, and we are not getting any object. So how are we gonna get object? That's a good question. To answer this question, we have to know that insert or to get a value, you need to use the third brackets, and then we will give the index. So this is in the index 0. This is in the index 0. This is in the index of 1. Sorry, 200 is 0. Index is 0, and the index is 1. Index is 1. So how will we get 100? You have to give the index. So let's go ahead and say 0. Now the 0 will mean this is the index, so 0 will mean it will return 100. So save. Let's go ahead and open up Unity. We'll hit play, and as you can see, the 100. Now you may have a question or may not have a question. How can we get all these values, right? In the next lesson, we will show you exactly how. But for now, I want you to play around with these and try to mess up with these. In the next video, we'll actually not show you. In the next video, I'll show you how you guys can use complex lists and how you guys can use this practically. So thank you for watching. I will see you in the next video. Welcome back, everybody. Welcome to this course. I want to congratulate you that you stick to this without skipping. If you've skipped, screw you, but don't leave, please. So let's get straight to the list. I have created a pattern. I have created a couple of cubes. So I want you to first create them. Then why we are doing that? Because what I'm going to show you is how can you take each of them, and when I click of a button or clicking on the mouse, it will change the material of each one of these cubes. No worries. So if I have like 5 cubes, 7 cubes, 8 cubes, it doesn't really matter how many cubes are there in the scene, but it will do this. It will just change each of these cubes material to something else. Private type. Now there are 2 types. Number 1 is the mesh renderer, which we will use. So mesh renderer, and I'm going to write renderers, and we need just 1 file. So basically serialize field private material material, and then we will just get them. How are you trying to get them? We are gonna try to first, let's see, let's go ahead and get them first. So let's say mesh renderer render renderer equals to renderers and then say 0, the first one, and there's error. No, there's no error. Okay. Next, what I'm gonna do is write renderer dot material equals to material. And if I hit save, now what will happen, let's see what happens. The first instance of that cube will be no change. Seriously? Oh, sorry. I didn't add anything, which was a stupid thing to do. So first go ahead and click on test. Then this button will show up. This button will be there. Just click on this. And then what I'm going to do is just copy paste like this. Then give it a material and then go turn it off and run. The first instance is changed, but I want each instance to change. How are you trying to do that? But before I even do that, I need to pop this into a simple if statement. So input.get mouse button down 0, and then put this guy there, and then save. And when I hit, oh my goodness, seriously, bro. Okay, for now, don't do that. Okay, sorry I wasted you a little bit time, and we will do this later. Okay, whatever. So render.material will set this to the render.material. In the next video, we will look at for loops and how they can be used. So let's go ahead and do this. Welcome back. In this video, we'll be talking about for loops, and let's get straight to it. So how are we planning on doing, what is a for loop anyways? Before I even do anything, before I do even anything, just let me remove all of this crap, and let's go ahead and let's see what our for loops are. So first, let's write public, because that's not my thing to do. But for the time purposes, I'm going to do that. Public int x equals to like that. Okay, x public, sorry about that, x like this. Okay, like that. Okay, so then in the start function, I'm gonna print every value of x. So how are you trying to do that? Just like save and into the test. Into the test, we have ourselves a x, and then let's go ahead and add some things. So let's set 20. The value, let's go for 3, 20, 50, and 30. Okay. Now I want these values. How are we trying to do this? There's two ways to do this. First, using the for, both are for loops, but there's a little difference. So there's one called for each, which is really good for this block of code will run this amount of time. So if x's value, meaning there are 5 elements into the x, then this for loop will run 5 times. That's about it. You don't need to worry about how everything works. If the x's element is 10, then this for loop will run only 10 times. That's how it works. Okay. Okay, so what I have to do first is using, and then we'll just get the print. I cannot say print. Come on. There you go. Print, and I'm gonna do is x index of. So it can look a little weird. So it'll look a little weird. What is happening? So run this about this amount of time. Then what is this I is doing? When the I runs in the first time, I will be 0. When the I runs in the second time, I will be 1. And you know, the first run is I0. Now, in the start function, let's just give it some values first. So let's say, no, there's already given values. Let's just look at over here. Come on, quick, please. So if the first value is 20, the second value is 30, and the third value is 50. So the first value is 20. So the first value, when the I is 0, you know that what this guy will return, x index of 0. I have a question for you guys. What this will print? X index is 0. What this will print? If you said 20, then you are right. Because the first value is 20. Then the next run, I will be 1. Okay, the I will be 1, and this guy will be 1. And when this guy will be 1, now which element it will put? The 31. Then the next 50, then next. That's how it works. So when I say I, you know how it does. If you're still confused, feel free to comment down below. Okay, so we are going to do that. And when I run, and it's, as you can see, 20, 30, 50. That's how it works. Hopefully you are getting familiar with how this programming thing works. There are a lot of things to cover. So stick with me. It will help the algorithm. It will help yourself. It will help everyone. Thank you very, very much for watching. So we are done with the print guy. Next, that's what I wanted to show you. There's another type of loop, which is much more easier for you guys who are lazy, is the for each loop. For each loop basically does the same thing. So for each item, let's say integer, and I'm gonna say x item in collection. Now this collection meaning the x. So for each item, I'm gonna say each item in x. See, it's so easy to read. For each item in x, print each item. Now this guy, when I hit save, so go over here, and it's going to 20, 30, 50. That's how it works. Okay, so that's how for each one works. And now what I wanted to show you, hopefully you guys understood what is going on, and what I wanted to show you, and now you know what we will do. We will use both. So let's say for, because let's get each one out of the way, and we will say length. So length will be the renderers.length. So renderers.length, renderers.range, which dot count, sorry, count, there we go. So for each renderers count, then we know how to access them. So what we'll do is say renderers index of I dot material equals to material. And when I hit save, and we need to put up some values because this is empty here. What I'm going to do is just wait a second. Go ahead and go, damn it. Go to, and I'm going to just block this guy in. Go here. Do that. Change the material and hit save. And each guys is changed. Okay, now you know what to do with this and how to use them. Same for each one. So let's do this again. Sorry, let's do this again with the for each one loop. So for each mesh renderer, we have said render in renderers. For each renderer in renderers, what we need to do is take that renderers, not rer, dot material, let's do material. And if I hit save, and you will see the same thing results, but I used both for statements for each and for to get you guys. And as you can see, this is how it works. And if you want to enable, just go ahead and remove the private, use the update, and use the if statement, input.get mouse button down 0, and then we put this guy in for each, and boom, 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 and boom, and I hit save. I go back. Now it's a little bit longer, but I want to give you examples where you can use them, and when I click on it, it's changed. That's how for loops can be used. There are multiple type of behaviors can be done with these, just those things you have learned so far. So thank you for watching. I will see you in the next video. Yo everybody, in this video we'll be looking at dictionaries. So let's get straight to it. So what are dictionaries? Dictionaries is basically a key value name system. Now that's some technical crap, but the key value meaning a key means, for example, name, cryptic. What I have to do is just say dictionary and then say string and then say string. Then let's say I would say name age. This is not a good name, I know. And name age dot add. Then we would do is just add a, say for example, name. Let's say name, that's the key, and let's say 20. I don't know, just okay. So basically, let's go for a integer. So basically the string will be what's known as a key, and the value is an int. So the string will be, if you use JSON, basically the simplest type of JSON there is, basically a dictionary. So then where is it useful? It is useful in inventories. So I'm going to show you one sec, but for now, let's go ahead and just print this guy right here. So basically name age, and then we pass in name and save this guy here, and let's go to our Unity. Our Unity is whacking, so let's go ahead and start this guy. No errors, please. No object reference is not okay, obviously. So basically we have to say we need to initialize the scrap here. So basically new dictionary like that, and boom. I know there will be an error, but still let's try it again. Let's try it again. Boom, it worked. Now the reason it didn't work in the start when you're trying to do it, because we are using the wrong method. For dictionary, it works. For list, it will work. For basically any type of variable, it will not work. Because I tried one, it didn't work. Literally don't tell me why. It's just how C# is built, which is a good thing. So we have ourselves a name age, but for now, let's go ahead, and the name age looks kind of crappy. Let's say inventory, right? The inventory. So that's a little bit much more cooler name. Let's say inventory dot add. Let's say sword, and the power of the sword goes. How many swords I have? I have one sword. Basically, I have the master sword if you played Zelda. So inventory dot add. Then let's say how many coins I have. So I have 200 coins. Okay, so basically like that. And in the next video, we'll show you how you guys can access this inventory and create the database part. But the database is much more advanced, so we'll not cover this now. But it will use JSON and stuff. But for now, just understand the basics. The coins is 200. So same for now. The power of dictionaries is you can just call the name. So I want the how many swords I have, return how many swords I have, like that. You're telling to the game engine how many swords I have. This is some powerful thing if you're understanding where is it going. So what I'm gonna do is just say boom and boom 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 1. I have only one sword. Wow, why? Okay. inventory, how many coins I have, how many things I have, and there's a thread. Look at this, and there's a dictionary because I'm gonna teach you how to actually think. So this guy said that you can actually do this, like the Apple thing. We have done this, and let's see, go above here. And let's say, wait a second. What I was doing, by the way. Yeah. Wait a sec. Yeah, there you go. Fruit apple equal to right. There you go. Now, what I was gonna say is the inventory sword. Then, if I want to say add a sword, what I'm gonna do, right? So, do you have if you guys have the concept called returning something? Basically, you throw a rock and somebody throws rock at you. That's how it works. You throw something and it returns something else. You do a good deed, it just returns, right? The concept of karma. That's basically how it works. It returns something. You give something and you return something back. So what returning mean is, when I say this, just this, what it returns is a value. So it's a 1, right? And yeah, this is what will return. So then I can say, let's say equals to 2, and let's go ahead and save. Let's see what happens. Let's see what happens. And let's see what happens. As you can see, 2 is returned. So you can add more stuff if you want. If you want to add one. That's how inventory is built. In the next chapter, what we will do is we'll try to understand how can we use inventory and how can we get all of those values, how many things are, which will be pretty fun, to be honest with you. So stay tuned. Let's do this, and out. Welcome back, everybody. Cryptic here, and in this video we'll be talking about classes, and we'll look at what are classes and what are objects and how you guys can use them. A class is a blueprint for an object. A blueprint is simply a factory. Think about a factory. Imagine a factory, and the thing that comes out is an object, and that factory is a class. And if I have to say another way, an architect, before it builds a house, he creates a blueprint, and depending on the blueprint, the architect creates the house. So the blueprint is the class, and that house is the object. Hopefully, you guys understood what I was talking about. And now let's go ahead and go to some practical examples. So what I'm going to do here is I have 3 classes. Actually have 2. So we have ourselves an animal class and a zoo class. We'll talk about those in the second video, or what a bird and penguin does. But for now is an animal class and a zoo class. So the animal class, what I'm going to do is let's make some functions. So let's go ahead and add a sleep and add a eat. Okay, so sleep and an eat, right? So sleep and an eat is a function that has been used for the animal. So the animal's main behaviors are sleep and eat, right? So the functions that we have access to sleep and eat. Now, these are the blueprint. When we will create, we will have access to these things. Now, we will have some, let's go ahead and create some, maybe some names. And public int age. And then we have ourselves some variables we can go ahead and access to, we can set up. So let's go ahead and create a animal in our zoo. So in the zoo, what I'm going to do is in the start function, we're going to talk about animal, and then let's go ahead and add a lion, and let's go ahead and say new animal, and then I'm gonna say lion dot name equals to maybe lion. Yep, lion name. Okay, lion dot age. Let's say it's at 12 years old, maybe more. Maybe it's, let's say it's 18 years old. And I'm gonna do what I'm gonna do is just say print, and let's say lion dot name, and let's see what happens. Now this is an object, and that thing is this is a class, and this is an object. So let's go ahead and see what happens. First, make sure you put the zoo into any object of your preference. I'm using the test object, and then I'm gonna do just say let's run our script and let's see what happens. As you can see, the lion name got printed. So the power of an object is I don't have to code all of this crap again. What I'm gonna do is just say, let's say cheetah, maybe bear. Say bear. So new animal, and then I can say the beer.name and same crap right here. So we're just gonna copy paste beer, and beer. And let's say it's beer name goes here. There you go. That's his name. And it's about 20 years old. And I can put the age and the name as well. So let's go ahead and do that again. Let's see what happens. So beer name. And I'm going to do is just go ahead and open up our Unity and run and see what happens. Hopefully it's recording. So as you can see, lion name, bear name goes here, comes over here. And then what I'm going to do here is go to over here, and we need to make sure that we have ourselves some public functions, all that crap. So that's how basically how the animal works. Now there's another simpler way to actually put these things here. So what's known as a constructor? Now what is a constructor? Constructor basically calls when the animal runs for the first time, and when the animal class runs, basically the constructor runs first. So how to create a constructor? You will write animal, and then you put like this. So animal as a function. So animal as a function. Then let's go ahead and put some say animal name, and int animal age, and then what I'm going to do is just say name equals to animal name and age equals to animal age. Then what I'm going to do is just go ahead and leave it there. Now, if you look at the official inheritance documentation, you would understand that how it works. So what it does is, let's see, there's another function that was pretty cool. It was, where is it? Where is it? Okay, so it is in here. There we go, the flute style class. Come on, go back, please. So in the Apple class, we have ourselves, wait a sec, where is it? Okay, it's called public Apple. Sorry about that. We need to add a public here because it will not work instead of that. Okay, so the public, and we have ourselves an apple string animal name and animal age, and we set up these variables. And as you can see, we have ourselves some stuff going on over here. So so we're gonna go back, and we have ourselves some color, and then we set the color. Okay, so that's how you create an constructor. So let's go ahead and let's check out how you guys can use them. So go ahead and go open up your Unity, and then there will be a million different errors, and you're gonna pop that thing out, and let's see what happens. String animal name. So the animal, there's there's multiple constructors you can add. So let's say if there is no animal, so if there's no statement, then a name equals to blank and age equals to blank as well. So you can have a multiple different constructors if you like. So let's go ahead and save this guy, and into the zoo, I'm going to add another one. So let's say animal. Maybe let's think about how many animals are there? Let's add a eagle. So eagle means, then I'm going to say new animal, and then I can put up, as you can see, animal to animal, there's a string and there's int, and there's none. One, come on, man. I can, come on. Okay, well, there's one overload. So I'm going to write here, let's say it's an eagle name. Now I know I'm boring, but I cannot come up with different things, mate. So let's go ahead and let's add a eagle. Now print up eagle dot name, and I'm going to save this guy, and let's go over there again, clear up this crap, and what? Oh, sorry. In equals to, let's say 0. Save that guy. Save that guy, and it should work now. Yeah. So let's go clear this guy up and run this guy again. And when we're running again, so eagle name pops up. Now without this thing working, it wouldn't have been worked. So that's how you create. That's what's the power of constructors are. You can have multiple different constructors if you like. That's not a problem. In the next video, we'll be talking about inheritance and how you guys can use them. Thank you guys for watching. I'll see you in the next video. This video. Now, data encapsulation sounds like really mouthful, but it's actually really simple idea. What it does, for example, we have ourselves some player. Okay, we have ourselves some player. Now, what we want to do here is we want to get this instance and check different values and change different values depending on some things. So what if what we want is in the my game manager, I want some information about the player and what's the current state of the player it is in. So how can we do that? First, what we need to do is into the player script, we have ourselves a player with the mono behavior class, and we need to put some things here. So we need to put maybe some variables, some functions, and all of that crap. So after that, we know that it is time to move on. First, you need to know that we need to create a public function, not a private one. So let's go ahead and write a public void does something, and let's just print it works. Okay, then I'm gonna save this guy and go onto the game manager class. What I'm gonna do is just save this game manager class. I'm going to into the start, when the game starts, well, we need to take the player. So how can we reach to this instance, the player instance? Remember that we don't need to get the player C# here. We need to get the player instance over here. We need to get the player instance over here. How can we do that? Well, there's a zillion different ways to do that, but the simplest one is adding a player tag. Now, player tag is simply a tag that is only resigned only for the player and not for anyone else. Now, you can add finish if you want, but it's generally easy and more recognizable that you add the tag player. That makes more sense. So let's go ahead and add it here. First, what I'm gonna do is into the start function, I'm gonna check for the player and get its instance. So we're gonna say private player current player. And what I'm gonna do is just say current player equals to game object dot find find with tag. Then I'm gonna specify dot player dot get component, and we need to get the player component. Now, why player? Because the script name, what we are doing is saying to the game manager that, hey, find an object that has a player tag in it. So this guy has the player tag in it. So it will go there. Then I'm telling the script to go down and find the player and then go ahead and add to this variable. So current player is been set. Now what I'm gonna do is when the game starts, for example, when the game starts, I can show print. We can add the we can add do something. Okay, do something, and as does something. Okay, does something. So I can call the functions over here. Then I'm gonna save. Then I'm gonna save and then press the start button. So when I press the start button, it prints. It works. Without the getting, it will not be able to get the does something class, the does something function to run. So I can print current player dot. Let's go ahead and see. Remember, you need to put your we need to put your variables public before you can do this. But it is generally a bad practice for to making your variables public. So what we can do is create a function. So for example, I want to get the player speed. I want to know what is the player speed right now. What I'm going to do is create a function that returns the player speed. How can we do that? So return player speed. So how can we do that? We can write public. Then I'm going to write int get speed. Okay. Then what we can do is just say return player speed. What is the variable again? It was player speed. And we now know that we can get it's in the float. I can have to make sure it is in float. Okay. So we can save and I can now say get speed. I can have the access over here. Then I'm gonna what is going on, man? Okay, so I can get the speed. So what I'm I will do is just run the game, and the speed is 10.24. Now if I increase the speed here, and it will not work because it's not running every single frame, but still I can change this to 37.75. Then I'm gonna run and it will be 37.5, and let's just make it 10.4, and let's go ahead, and that's how basically data encapsulation works. And what we're trying to do is taking different things, and then we are changing different things. Now can you change the speed value? Of course. What we can do is just simply public float set speed. Now remember, you need to know about the functions and how the parameters work, and new speed, and I'm gonna do is just say player speed equals to new speed, and I'm gonna save. Then I'm going to say current player dot set speed, and let's go for a value 12.34, and then I'm going to print this guy again, current player dot get speed. I'm going to save, and let's see what happens, and let's see what we can do. I write set sped. Wait a second. I hate writings like that. So speed. Save, and I'm going to write this again. Let's go ahead and just delete what? Not all code pass return a value. Sorry. And to make it void, because the function doesn't return anything. And let's go ahead and start the game. Now what, mate? Double float value. This is a double value. Interesting indeed. So I need to create a new speed over here. Let's just go the easiest fix for this problem. Please, no. This is, by the way, this is called casting. For those of you who don't know, this is called casting, and if it is a floating value, you can make it an integer, you can do whatever kind of things you want to do with it. Basically, you can change the value. So I'm going to run this again, and as you can see, first it was 10.24, then this guy ran, and now the value is 12.34. So I can change things from here. Now think about how can I use this knowledge in probably your game, because this is really, really handy. So thank you for watching. I will see you in the next video. What's up, everyone, and in this video we'll be talking about inheritance. So let's get straight to this video. So first, what is an inheritance? Inheriting meaning getting from the parent class, everything that is from the parent class, and the child will get that parents every single thing from the parent. So it's I know it sounds really weird, but how it works is let us take example. An animal, we have ourselves an animal. So an animal class, we have something going on here. So if I want, a penguin is an animal as well, and a bird is an animal as well, right? But what it has is I don't want to code all these things again. So for example, if this guy was about like 200 lines here, and then we have ourselves eat, which takes about 200, basically 400 lines. I don't want to code whole that crap over here and over here, because that would take a lot of time, which makes zero sense. So what we can do is inherit from the animal. So we were inheriting from mono behavior, and we were inheriting from this guy, but we will inherit from the animal. Now, the best part about these guys are the animal is inheriting from mono behavior. Then what happens is the penguin is also inheriting from mono behavior as well. So yes, we have also access to the start function. So that's how these types of things work. Basically, the animal is the part of a part of animal, but there are basic functions are already implemented. So what's the real hand use case of these behaviors, may I ask? The real hand use case are the artificial intelligence sector. So in game programming, we need to change different states of the game. We use lots of different things for changing the state, but the best way to do the artificial intelligence is using the inheriting. Basically what it does is, if I add like that AI as a parent class, so think about the animals is AI, then the AI as the parent class, then we will inherit the penguin from the artificial intelligence. Then it would have some basic features. Basically, this is a blueprint, a parent blueprint. Cut it down. Okay, so this is the parent blueprint, that animal we got over here. Maybe in artificial intelligence, let's take example, then we would have a chase, we would have let's say maybe shoot. But what's the why did I create different penguins and birds here? So what's the difference between a penguin and an animal? It's an animal, but penguin can swim. Not all animals can swim, but a bird can fly. Not all animals can fly. So you need to think about, so what's the power of inheritance is when I'm going to code the bird, I don't have to code the whole crap again. I just need to code what's the difference. What's the difference between an animal and a bird? That's what I need to code here. So that's the power of inheritance we got here. So in animal class, we have ourselves some things, and I'm repeating the same crap again for no reason. So the penguin is an animal, and we have ourselves swim, because a penguin can swim. Not all animals can swim. So if you take an artificial intelligence example, so let's go ahead and let's see here. So we have also the enemy, right? So what if we had, like, let's say helper player. Okay, so we have ourselves a helpful player here. Now, this guy is not our enemy, this guy is in our side. So if I have to code this guy is also an artificial intelligence, this guy is also an artificial intelligence, what's the difference between these two? This guy will help me kill that player, and this enemy will attack me. So if you played a lot of games, especially single player games, you would have enemies and helpers, right? If you say side characters and stuff. So that's how you create. These are two artificial intelligence, but the main difference is this guy will kill and this guy will not. So when I'm gonna code, what I'm gonna do is inherit these two guys from the artificial intelligence, and but then what's the common functionality? These two is maybe will walk, maybe will follow the player, maybe will do some crap like that, right? This is the common between these two people. Artificial intelligence. Okay, so these two guys have these things, right? So I'm gonna just code that chase the player, and this guy will not have chase the player. What it will have is just follow the player, and then when it comes to an area, certain range, you shoot that damn thing, right? That's how basically how I'm gonna code, how I'm gonna go about coding if I'm gonna code that thing. Hopefully you guys understood what I was talking about. Now if you don't, go ahead and comment down below and share this with your friends and family. If you have a team, go ahead, share this with your friends and team members. So thank you for watching. I will see you in the next video. Welcome back, everybody. In this video, we'll be creating a character controller. Now, this character controller is a little bit complex. I will try to explain. I do try to explain my best as I can. If you don't understand, that's completely fine, because a lot of stuff is not like understood really well. But I'll try my best to make sure you understand what is going on. So first, we need some things. What we need is a player body, but this guy is really I don't really need, but it is really nice to get the rigid body, because if I want to add a force, like for example jump, which we will add maybe in the next videos, but maybe not, but it's a really good practice to just add the rigid body, and if you don't worry, it's fine. So we have ourselves a player speed, we need them, and we need an angle speed, because we want to angle the 180 degrees rotation on the, let me teach you. Wait a second. Where is it? It's in the this axis. We need to move the y-axis so it will rotate towards. So let me just that. Okay, so it will rotate towards. So we need a vector3 movement. Now this movement is the variable that will be responsible for the movement of our player. So let's go ahead, and these two things, the h and the v, is basically a placeholder variable that will be depending on the horizontal and the vertical of our axes. I will teach about input axes a little bit later. Depending on that, the h and the v values will be there. So all the code needs to be done in the fixed update, not in update function. The reason is really simple. For movement, we will use the fixed update, but for the general updation, or every single time, like score getting updated, you will put that code into the update function and not in the fixed update function, because this is really for the movement and the vector calculations and stuff. So anything blasting, anything moving, you will put that into the fixed update function. Okay, let's go. Sorry about that. So the h is input.getAxis horizontal. The reason they get axis and y horizontal, the get axis basically gets the every horizontal axis, and depending, let me show you. First, go to edit, project settings, input. Where is it? Sorry, not here, I think. Input manager, there you go. So in the axis, as you can see, the horizontal there. Horizontal is a left and right, and the keyboard and mouse button and the jaw motion from all joysticks. So what it basically does is simply when I hit the D key or when I hit the right arrow, which goes to the right direction, is basically will be 1. The input.getAccess horizontal will be returning 1. But if we are using a motion controller, the joystick to the right is 1, and in the middle, the joystick's middle part is 0, and a little bit to the right is 0.5 or 4, something like that. But the right and the left will be 0, 0, and the left will be 0 and the right will be 1. So the V, the input of the getAccess vertical, is the same thing. Let's go ahead and let's see. So edit project settings and input manager, and into the vertical we have ourselves the up and down. So same thing, up is the horizontal up is -1. So when we go up it's -1, and when we go down it's 1. So the next step is we translate that variable using the vector3.forward times v. Now v is the vertical because the vertical axis is up and down, so the forward and the backward movement we will use the player speed, but for the rotation we need to use the angle speed, which is the 180f. So the forward and backward we will be using the vertical one, and for the rotation which is in the horizontal space. Why? Because we are using the left and right, because of the rotation will be done by left and right. This guy is in the angle speed because of 180 to move the player. Now what is this time.delta time? Time.delta time is basically for smoothing out the process. So if my computer can able to handle this game in 60 frames, and but another computer can handle into the 30 frames, so the calculation doesn't mess up. So it will be as smooth as possible. That's why every rotational movement, every movement is multiplied with time.delta time. It's basically the last frame, the time it took to load the last frame. Now that's a little bit complex, I know, but yeah. Time.delta time is basically smoothing out the movement as possible. Then we use the transform.translate, which translate means move. Vector3.forward because we are going to the forward direction. Vector, if I hover over it, let me just go ahead and see. Come on. Okay, so let's go ahead and write vector3.forward and forward. Let's go to the scripting API Unity, and the forward is vector3.forward is vector3001. If you can see this really quickly, this vector3 is vector3001. Okay, so we understood that this is into the z-axis because the movement is done in the z-axis. So now it's time to rotate. To rotate, which is the rotation, we use the vector3.up. Let's look at what vector3.up is. So let's say vector3.forward now, up, and let's see what it does. The stupid idea, the code editor doesn't work for some reason, and my Wi-Fi is BS. Come on. Oh, I know. Vector3.up is the up axis, and it's, come on, mate. Why it's not working right now? Vector3.up and vector3.up, and vector3 is into the, this is 0x and this is the y. The y axis will be 1. So the y-axis 1 and times by multiplies by speed. Now how this calculation works, I'm going to explain so you get crystal clear idea. Okay, so you get the crystal clear idea. Make sure it's the rotate is the bigger hand, the capital form. Okay, so how this thing works is using, let's go ahead and see. Vector3, this thing, the vector3.forward returns the vector 3 0 0 1. Then what it does is the v, whatever the value is, let's look at, let's say it's v is 20, v is 20. Then this the vector 3 dot 0 here is 0 is multiplied by 20, 0 is multiplied by 20, and 1 is multiplied by 20. So what it does is 0 by multiplied by 20 is obviously it's 0. Same for this. And the 1 times multiplied by 0 is 20. That's how the vector calculations usually work, which is super simple. Same for the up, but in this case is the y-axis. So hopefully you understood how vector 3 can be useful, and if you don't know what are these there are a lot good documentations out there. Go ahead and check them out. Thank you for watching. I will see you in the next video. Welcome everybody. In this video we'll be coding the camera, so let's get straight to it. First, let's go ahead and click on the camera and we'll add our component to it. And let's go to the scripts, right click, create a C# script, camera. Make sure your every instance, every particular way of every component that you add, to every game object will be different script. So divide your logic into different segments. So camera, enemy, player, gravity, etc., game manager, and other things, right? So go ahead and let's code the camera. So in the camera, we'll use the late update, as you can see. So first we will do is go ahead and that. So let's go ahead and add target to follow. So let's go and write public game object target and public float speed camera. Okay, and in the late update, what we'll do late update, I'm gonna say target dot position transform dot position equals to target dot transform dot position plus offset. Now what is this offset guy? Offset guy I will explain. Before that, let's just go ahead and create offset. This guy is when, okay, it's better to show you guys. Yeah, so like the simplest form of camera. Put that guy to the main camera script, and it's there, and the camera speed a little bit like that. Did I use them in camera speed? No. Okay, we would use the vector 3 and other crap later, but let's go ahead and see. Without, I'm using 0 offset. Okay, let's see. As you can see, I'm in the middle of. Okay, that's how I work. I am in the middle, right? So I need to make sure that I am a little less there, so -10 upwards. This would be fine. Too much. You can actually change. It's 2.96. Nice. 2.96. And run this game again, and you'd see, as you can see, it works nicely. And when it comes in the next video, we'll be making that when it collides, we will restart the game. That's what we'll do in the next video. So thank you for watching. I will see you in the next video. Welcome back everybody, and in this video we'll be talking about enemies and how you guys can create your own artificial intelligence, and that's what I was promising. A couple of videos later, a couple of videos after. Wow, I cannot speak English today. Couple of videos before. That's the right word. Okay, so let's go ahead and get straight to it. Yes, okay. So let's get started by creating a new script, and I have zero clue how am I gonna code the enemy. Seriously, I don't have a single clue. Will we use AI? Yeah, we would see how it's going. So first we want a target to follow. So we would just go ahead and write serialized field private game object target, and we would want a speed. So let's say enemy speed. And then in the update function, let's still look at fixed update function. Fixed update function. Let's just go ahead and remove this guy. Fixed update function, and then we will first we would check that if a certain distance is been there. So there's a certain distance that the thing that provided. Okay, so the best way to do this is there's two ways. First is, I think it's not really dependent. So let's go ahead and do that. First, let's go ahead and create a in the enemy scene. What I will do is I will let's create a new let's see which one should I create here. Yeah, like empty game object. I will just send that to enemy, and this is a way to do it, and there are a lot of ways to do it, but let's go to the main. Sorry, let's go to the easiest way, because that's gonna take a lot time. So what we are doing was the enemy speed. Then we need a certain distance. So serialized field, a certain distance. So private float a distance to follow, and we would give them. First, let's look at the concept of functions. Now these are Unity defined functions. That means this is from Unity, and it does a specific thing. There is also a user defined function which we as programmers decide. A function is just a block of code. So I'm gonna say private. Let's go ahead and look at the concept of integer. Get distance, and what we'll do is we will return. I'm going to show you. Return the vector3 dot distance. Let's just go ahead and add them to a variable. So let's go ahead and say integer. This the return value will be a float. Sorry about that. So float. Float. And let's go ahead and say float dist equals to vector3 dot distance, and the vector3 dot distance function takes two vectors. So I would say transform. So now where I was at was the distance between the transform dot position to target dot transform position. And if you're using a transform variable, you don't need to use the transform. Okay, so this will return, and we will return the distance. And what we'll do, it would take this two instance. So for me to the target, how many position are there, and if it's the distance, and it will return distance. Now we will say, and let's create another file which would private, right? I would say, let's think of a name, follow, and the follow command or the follow function will return. Remember that these things need to be called. The user defined function to be called. Now we will go over here and then say if get distance, and you guys already know how the returning works. If you don't know, basically it will cut it out, and the distance, for example, is 20. So 20. This would what exactly how it works. So if the distance is less than distance to follow, just follow, that is the case, then we know it's time to follow. Now we would first let's what can we do? There's multiple ways to do this. First, what we can do is get the direction, and then we force. That would work as well. So let's think about it. Let's think about it. Let's think about it. Let's think about it. So let's go ahead and go to direction route. So direction equals let's say to direction equals to the I got it. So we would do is try get minus, and this would give you a direction. Then we need to do is say transform dot translate and the direction times by a certain amount of speed. And say and speed times by time dot delta, and this guy should work. But before that, let's go ahead and we need to call these functions in the physics process. So follow. And remember, there are two things that I want to show you. First is the distance will return, and there will be, and I think there is a part where I explain how these things work. If you don't know, go ahead and recheck them. And yeah, I'm not going to explain a lot here, but there is one. You guys should watch it. So okay, we are done. Should be done. And let's go ahead and try to test. And I know that this will work. In the first run, nothing works. Then that's by grace of God. Okay. So we would. How do I add them? Wow, nice. Very cryptic crap. And the target we're trying to follow is there. Enemy speed a little bit more than, and the distance to see. And lo and behold, and as you can see, our guy follows. Oh my god. Okay, it works. Okay, so as you can see, this guy is not following, and we would, and as you can see, now following. Now, there's a way of destroying the destroying the game. What I'm saying, restarting the game. There's a really easy way to do that, and I'm gonna show you in the next video. So thank you guys for watching. I will see you in the next video. We would name it Game Manager. And let's add a new script. Manager. Game Manager. And then, as you can see, this is changed. So to identify that this guy is the game manager, which is a nice addition to Unity's latest versions. And I'm gonna just remove everything. And I'm gonna create two functions. So for number one is restart. So now we need to use the public keyword. So I'm gonna use game manager from, I can use it from anywhere. So that's why I'm gonna use public void restart. And to restart, now we will use a new using statement, which is basically an import. So using Unity Engine dot scene management. Now, scene management, this part will show you that it's using the scene manager equals to scene manager dot load scene manager manager dot get active scene dot build index. And I wrote it so many times, so I know it works. Okay, so this is how you'll do the restart of a manager class, and we'll just say in right the closing the game. But for now, we'll just go ahead and go write the start, and we'll go and create another one for go to next scene. But we will maybe use this later. Go to next scene. Go to next is scene manager dot load scene manager dot get active dot build index plus. So how this works: scene manager to load scenes loads the scene manager to get active scenes get the active scene what we are playing, then it gets the build index. Now you can use the name property, which basically returns the string, but I will use the build index, so I can say that when the game runs, we will when we are trying to go to the next scene, it would get the build index and just add one. If the build index is 0, it's like a list. Okay, so this is like a list. This guy will return 0 for now because this is the first level. Then we will add 1. I'm going to show you how you guys can add more levels later, but that's a Unity specific video. Go ahead and watch the Unity video. This is the Unity C# video. Okay. So we are creating the restart. Now we need to call them. How am I going to call them? Well, if I make this class static, I actually forgot a little bit here. Public static, I know. Hopefully, it would say game manager dot restart. It can load them. So into the player, I would create an on collision enter, and you can write just on collision enter and hit enter. Then this guy will pop. So on collision enter, if then I would check if other dot game object dot tag compare tag. I don't know how I remember all these things here. Okay, if the other dot tag is split, tagging is basically for identification of a specific object. So if the other dot game object is tag, then what we'll do is let's see, I'm gonna say scene game manager dot start. Will it work? Please work at first time, please. Static classes must be derived from object. Okay, it will not work. Sorry about that. The static class will not. So I have to create a game manager. What I'm gonna do, start function, and then we would managers, and I would say private manager, and then let's say game manager. And in the start function, I'm gonna just write game manager here. So game manager dot manager initialized game manager here. Even another easy way to do this is using the serialized field. We'll just put that game manager down, and I don't need them. I don't need to initialize there. So the game manager, and then I can use the manager dot restart and I have myself simple collision detection system. So private void on collision enter is a Unity specific function. It takes a collision of other. Collision means the collision between two objects. When it happens, other will take the information of this object has been hit. Then we would get the game object of that. Then we will say compare tag to say if it's player. Then if it happens, then restart. Sorry, if it's enemy. We are coding the player, so there will be no player. That is enemy, then restart. And yeah, that's how it works. There's another base programming I think we'll look at. It's a little bit advanced, called event-based programming. And I will try my best to explain that to you guys as well. But for now, let's go and save this guy. And let's see if it works or not. And the enemy needs to create a tag. So first, let's go ahead and give it a tag. Or you can use a name, but I do not recommend using a name. Go ahead and add a tag, add a name, and then adding tag over here. And then, yeah, it should work now. And is that it? Need to add? Yes, there is one thing to add. One thing that to add is game manager itself. That guy bad boy down, that thing. Then I will just run the code, and when I go come over here, boom. And what the heck? Okay, it's just changed a tiny bit for some reason. I don't know actually. The heck? I think this is because of the player and something like that. I don't know why it's happening. Anybody have any clues? See, it looks nice, and when it restarts, changes something else. We'll look at them a little bit later. That's how you restart the game, and that's how it works. So thank you so much for watching this many hours. I don't know what to say. Thank you for watching. I will see you in the next lecture. Welcome back everybody, Cryptic here, and in this video we'll be learning how to think like a programmer. So let's get straight to the video. First, let's write how to think like a programmer. Now, please do not care about the handwriting. It sucks, I know. So let's go ahead and just keep it let us get started. First, let's go click on this and let's make it a little bit bigger. This is way too bigger. This guy will be fine. Okay, so how to think like a programmer. There are two ways mainly you can think like a programmer. The first way is using in your mind. In your mind is how you use. This is a little bit way too bigger. Okay. In your mind. And another way, let's write that again. In your mind. And another way is in paper. And these are the two main ways that I personally think about solutions. But you can use multiple different ways if you like. The main part here is understand the problem first. So understand the problem first. You need to know what you're trying to solve. If you don't know what you're trying to solve, you'll not be able to solve anything. So then now the next part is breaking that thing down. So breaking it down. So the first thing is understanding the problem. The next thing is breaking this goddamn thing down. So how am I going to understand the problem? If you cannot understand the problem until you know what's exactly going on over here. So let's take an example here. So we have ourselves a plane, and we'll be adding a ball over here. This is your spear, and this spear wants to go up. To go up, there are multiple ways to do that. So that's my problem. I want this spear to go up in the up direction. How am I going to do that? First, you need to understand that is this a 3D or 2D? Maybe it's a 2D. 2D. So now the next part we need to understand is which techniques we'll be using. We will be using transform to move, or we'll be using, let's say, rigid body to move. You need to understand this as well. So I'm going to be using transform. Next is understanding that which direction we will be moving upwards. So obviously, is this a 2D? There will be a vector 2. So let's look at the hierarchy over here. Let's go ahead and look at the hierarchy. We'll go down here and let's look at the hierarchy. So we have ourselves the problem, right? So we need to clarify that, we need to question ourselves that what do I really need? What do I really need? So we have ourselves that this is the 2D. The solution is 2D. The another thing we have is we'll be using transform. And another thing we have, we'll be using obviously the vector 2 for the direction. Now we know that the problem is much more. Now we know problem much more. So the first one is done. Understanding the problem is done. Then we need to break it down even more. So we have broke all of this thing down as well. So we have done the second part as well. And now in the third part, what we'll do is solve it. Okay. So we need to understand is, if the solve it function, you can go much more deeper. So let's divide this thing. For this example, we'll divide this into two things. First is which direction you need to go is up direction. So up here we need to go. So the vector 2 dot up will give us the direction that we seek. So vector 2 dot up. Now how much will it take to go up? So we need another variable to declare that. So let's go ahead and write speed. So let's say speed equals to 20. So sorry, speed equals to 20. So 20. Then we know that up vector 2 dot up times speed will give us the friction it requires to go upwards. Now we need to feed that guy into transform. So that's how you think. You need to break everything down. Transform dot translate is the function, and the vector 2 dot up times the speed. That's how you go ahead and understand how to do certain things. Now this is a basic example. Everybody could understood if they think. Now there's another way to go ahead and to think like a programmer. The another way is, let's go ahead and clear the canvas, and is in the mind. So we talked about in the paper, and in this part we'll talk about in mind. In mind. So the firstly you need to understand is you need to think, you need to visualize that what I really want. So I want to go upwards. Upwards meaning the up direction. Up direction is what we need. Then we need a speed variable to declare how much the speed that we need. So in my mind it says that if we use rigid body it will also work. If we use transform it will also work. It really depends on your mind, and the more you do it the more it gets easier. So let's take another example so we understand everything. So let's clear the canvas and let's go ahead and take another example. Let's take an example of an AI. So the AI is right over here. So this guy is the enemy. We coded this in our Unity specifics part, and this guy is the player. And what I really want is the player, the enemy, what it will need when the player comes towards the enemy will go forward him and kill him. So that's how what we think that this is the problem we need to solve. So we need to define each and every object first. So player, what's the role of the player? Nothing. What's the role of the player, or what's the role of the enemy here? Is to first what it needs to do. First figure out what it needs to do. So the enemy needs to figure out if the player gets caught or not. We need to check for this or not. Caught or not. Okay, and then if it does, then we need to check. We need to go towards the player. So go towards the player. So that's the basic type of behavior that we want. This is what we want. The problem part is done. So now we need to deepen the understanding of what do we mean by if the player gets caught or not. So let's think, how can we achieve this thing? We need to check is the position of the player and the position of the enemy. Is if I minus this guy, we'll get the direction and how much is there the distance between the player and the enemy. So if we get the distance between the player and the enemy, we can understand that how much further away he is to the enemy. So how can we do that? What we need to do is try to understand that which part we will use. Will you use vectors to actually understand them, or will you use some other kind of stuff to understand them? There are multiple ways to do a simple thing. So the simplest way is using the vector3.distance function. So the vector3 dot distance. Now if it's a 2D 2D sprite, you can use vector2 as well, but we'll use vector3. So this guy takes two vectors, the enemy position. So our position, let's put this guy into the enemy. So our position, so transform dot position, and then the player's position. Now how am I gonna get the player? Well, to get the player into the code, you guys can use the get component by tag, get component by name, get component by maybe the player itself, player script itself, or any other ways you can get them. So player.pose. Okay, so this guy will return a float. So I can say float. Let's go change the name here. So a float dist. I'm gonna make it a dist equals to vector3.distance transform. Now then I can check for if the destination. Now the first part is done. If the player caught or not, we can check them. So let's go ahead and take this guy. And the next part is, if it does, then go towards the player. So now the first thing you need to know, how am I gonna go towards the player? How am I gonna check these values to a range? Now, and how much is there? How much is this? How much is this? So let's example, we need a variable to declare this. So let's go ahead and say range. And the range variable equals to, like, say 20. And then we can, wow, I'm making a lot of mistakes today. So if the distance is less than the range, then we know that we are indeed can check that we are towards the player. We are towards the player. Now, how am I going to move? That's the big question. So to move, there are multiple ways. We'll be using the transform.translate. And let's put in the translate, or there's another way. Sorry, we'll not be using transform. Let's use the lerp. So vector3.lerp. Lerp means linear interpolation. It just takes two vectors, a and b, and there's a t parameter that the time it requires to go from a and b, and the time is t. That's the main concept here. So this is the time it would take to go between a and b. So hope it makes sense. So vector3.lerp, then we know that our position. So the lerp from transform.position and to the enemy.position to, let's say, a speed of the time. So I know my handwriting sucks, so hopefully you're understanding what am I getting at. Now remember that there's no do's and don'ts. You just need do's or don'ts. You just need to understand what the heck the problem is and how can I solve it. This is another example of how can you use paper to actually understand what's going on, and how can you use your brain to understand what's going on. You need to think quickly. It comes with kind of experience, and you keep on doing it, it makes it much more easier. So vector3.lerp between the transform.position to enemy position and take a particular speed. I'm sorry, my handwriting sucks, I know. Okay, so this part is also done. Then we go towards the player, and that's how you do it. First, you need to understand that what it is exactly you are trying to achieve, and try to achieve it with your knowledge. That's how you think like a programmer. There are multiple ways. Another multiple way is using mind mapping and stuff, which is a little bit advanced stuff. And thank you for watching. I will see you in the next video.